Welcome to a third video on problem solving. This is the topic today is geometry. And so there's a few geometric formulas that you should be familiar with, and you can write those down, use them on the quiz if you want to. I would definitely have these formulas handy. So let's first consider this first problem where we're going to haul gravel to lay a 4-inch base for paving a driveway that's 75 feet long by 24 feet wide. It says, how much would it cost if the gravel cost $65 per cubic yard? And you can buy as little as 1/4 yard increments. So since the price of the gravel is it's sold by the cubic yard, then, and that's a volume measurement, I'll remind you that the yard unit is a length unit, that a square yard unit, like that, is an area, and a cubic yard is a volume. Volume. So we say this is, the yard is like, to the first power, we say that's 1-dimensional, 2-dimensional, and 3-dimensional. So just to remind you, let's say you take an inch, it's the same thing. If you have an inch, something that's 1 inch long, by that long, a square inch would be an area that covers a little patch. So this is 1-dimensional, 2-dimensional. We'll say this is 1 inch. This is 1 square inch. And then a cubic inch would look the same, except you would add another dimension. That is, you'd have some depth to it there. And so this would be called 1 cubic inch. Assuming it's, this is 1 inch by 1 inch, and this is 1 inch wide by 1 inch high by 1 inch long. So just so you know, there's these 3 dimensions that we have measurements in, and you want to be careful to know what dimension you're talking about and use the proper units, whether it's an area for square or volume, you'd have cubic units. So how much would it cost if the gravel cost $65 per cubic yard? In order to calculate the cost of that, we're going to have to know how many cubic yards it takes. So we've got this dimension, we've got a height or a depth of 4 inches. We've got a length of 75 feet and a width of 24 feet. Well, if I want to find cubic yards, probably the best strategy, I believe, for people is to convert everything to yards first. Put all your units into yards. So 4 inches, to change 4 inches to yards, we're going to take, and we need to know that 1 yard is equal to 36 inches. So those inches will reduce, and we get 4 over 36, which is, that's yards, is equal to 1/9. That's how deep that is. It's 1/9 of a yard deep. And 75 feet, to convert feet to yards, of course, we have to have feet in the denominator and yards in the numerator. So there's 3 feet is 1 yard, so our feet will reduce out. We get 75 over 3, which is 25 yards. And then the same thing from 24 feet, since it's 3 yards in every 3 feet in every yard, you divide that by 3 also, and that will be 8 yards. So if you don't know these formulas, again, I say write it down. This is a volume measurement. We're trying to calculate volume. So the volume here is going to be the length, 25 yards, times the width, 8 yards, times the height or the depth is 1/9 of a yard. So if you do that calculation, well, 25 times 8 is 200. And so that's going to give us 200 times 1/9, which is 200 over 9. And now, since it's yards by yards by yards, that's going to be cubic yards. Now, this we read as cubic yards. We don't really read it as yards to the third power, even though technically it is yards cubed, but we say the unit measure is cubic yards, which is our volume. And so 200 divided by 9, 9 goes into 20 twice with 2 left over. So that's 22.2 repeating cubic yards. And this says we can go by the nearest quarter of a yard. So we'd have, if you went by fourths, we'd have 22, then another fourth of a yard would be 22.25, then another quarter would be 22.5, then 22.75. This is by quarter yard increments. And 2.2 repeating, you're going to want to round that up to 22.25. So I'm going to say approximately, even though that would round off to, we know it would round off to 22.22, we need to buy in quarter yard increments. So we need to buy 22.25 cubic yards. Oops. Okay, so it's $65 per cubic yard. $65 per cubic yard. We multiply that by 22.25 cubic yards, and that, put that over 1. We reduce that, and we get 65 times 22.25, 0.25, sorry. And that turns out to be $1,446.25. Okay. Now, if you're doing this, you could, you don't have to, you could get 22.5 cubic yards, right, in real life. You don't have to round down to just the small as possible. A 4-inch base, some people put in a 6-inch base. So you could get 23 yards, or you can get more and just make the gravel a little bit deeper. The colder the climate, it's probably better to have a little extra than not enough, because in the colder climates, the ground, the freezing of the ground, it changes the dimension in that cracked concrete. So more gravel than less is better. So now let's go on. It says, how many truckloads would be required if the truck can only hold 3/4 cubic yards per load? So that means, now remember, this is, we have a total of 22.25 cubic yards, and we're going to be able to take 3/4 of a yard at a time. So one way to think about how we go about, how many cubic yards or how many truckloads it's going to take, is this is 3/4 of a yard per truckload, right? Our answer, we want our answer to be in truckloads. How many truckloads is it going to be? So basically, we're going to take this 22.25 cubic yards, and we're going to multiply it by something, and we want it to be truckloads. So 1 truckload, I'll abbreviate it TR, is equal to 3/4 of a cubic yard. And so you can see the units will reduce. Cubic yards and cubic yards. And so we get 2.25 divided by 3/4. Now I'm going to do that on my calculator, is 22.25 divided by 0.75, right? I'll just write it here. 22.25 divided by 0.75. That's how I'm going to do it. And that gives me 29.6 repeating truckloads. Now you can't go part way. Either you're going to get a whole truckload or not, or a truckload. You don't have to fill up the truck all the way, which you won't need to. You only need, you'll have to take 30 trips. No doubt about that. Now another way to look at it is, this division here, or this multiplication is, if you have to haul 22.25 cubic yards, if you're going to take away, it's like there's a pile out there, 22.25 cubic yards, you're going to bring 3/4 of a yard, then another 3/4, then another 3/4, and you're going to kind of chip away at this. I need a total of 22.25 cubic yards. I'm going to get a little bit at a time, over and over. And how many times would you be doing that? Basically, you're subtracting 3/4 of a yard. Oops. You're subtracting 3/4 of a cubic yard time after time. So that's repeated subtraction is a division. So you could have just divided by 3/4. It's another way you could have done it. And that would give you 22.25 times 4/3. Well, we divided by 3/4 here, so it's the same thing. So you could have done it that way as well. And both cases give you 29.6 repeating. Okay, so now let's move on to the next question. It says, how much would it cost if the gravel was located 14 miles away and your truck averages 13 miles per gallon, and wear and tear expenses are estimated at 16 cents per mile? It says use $2.75 per gallon for the price of gas. Okay, so we're going to be driving. Okay, you've got 30 trips, right? You've got 30 trips. Now, that's 14 miles away. But we have to go there and back, right? Each trip. So a round trip is a 28-mile round trip, right? So you could say if I've got 30 trips and it's 28 miles per trip, you're going to take 30 times 28, right? So you can just take, that's going to be 840. So you're going to go a total of 30 trips at 28 miles per trip is 840 miles total. Now, you get 13 miles per gallon, and this is a little trick on ratios, is if you get 13 miles per gallon, the typical way we set up that ratio is 13 miles over 1 gallon, but that's equivalent to 1 gallon will take you 13 miles. So you can take this 840 miles and you can find out how many gallons it's going to take you if you do that 840 gallons over 13 miles. Basically divide it by 13 miles and you're going to get 840 divided by 13 is 64.61 whatever miles, or sorry, gallons, right? Because our miles reduces out and we get gallons here. And so, and it costs you $2.75 per gallon. So we multiply that by 275, that's a 7. 275 per gallon. It's dollars. The gallons will drop out and you'll get 64.61 something times $2.75. And so that's for gas. The gas will cost $177.69. But it also says there's wear and tear. Now the wear and tear is 16 cents a mile. So remember, we calculated a total, should have noted that, I should have boxed that in. We have a total of 840 miles. And so we have to add at 840 miles, and it costs you 16 cents per mile. The wear and tear expenses are $134.40. So it says, how much would it cost? Well, I think this is for the fuel and wear and tear expenses. For the driving, that's going to cost you $177.69 plus $134.40. So we're going to add to that $134.40. We'll combine these two together, right? So the total, we'll say transportation expense is going to be $134.40 plus the $177.69. That's $312.09. And of course, you know, I said 12 and I wrote 19, but that's $312.09. So a little over $300. I mean, you know, you're not going to get exactly 13 miles per gallon. It's probably not exactly 14 miles away. And this is an estimated expense. So if you say somewhere around $300, that's reasonable. Okay, so let's go ahead and take a look at another couple problems. Here's another geometry problem. A water hose fills a 5-gallon bucket in 2 minutes and 15 seconds. Okay, 2 minutes and 15 seconds. First thing I think of when I see that, I think, I don't like mixed units. I don't want this to be in a mixed unit. I would like it to be either all minutes, which that would be 2, and 15 seconds is a fourth of a minute, right? 15 out of 60 is a fourth. So I'm going to think of that as 2.25 minutes, or 2 minutes is 120 seconds, plus the 15 would be 135 seconds. So I'm going to use one of those, either one, 2.25 minutes or 135 seconds. It doesn't matter. And this is a 5-gallon bucket. So remember, we've got the 5 gallons. This is the water rate, or fill rate, water fill rate. 5 gallons in either I'll just write 2.25 minutes. See what that does. It says, how long will it take that hose to fill a cylindrical pool that has a 6 feet diameter if you want the water level to be 40 inches high? And it tells us here that a 1 cubic foot is equal to 7.48 gallons. So notice I've got gallons here, and I know we've got 5-gallon buckets. So I would like to know how many gallons that pool is, because then I can use the 5 gallons in 2.25 minutes to do a calculation there. So now I want to just let you know there's several different ways of solving these types of problems, but I'm gonna try and take the approach of using dimensional analysis mostly. As you saw what I did up here before, notice this times multiplying by 16 cents per 1 mile. This is what we call dimensional analysis, is setting up those ratios to do a conversion. So our miles reduce and we just get dollars. As you see, you get all this reducing when you use the ratios. You can do proportions too, and then you just make sure you align, since it's an equation, you'd align units, numerator, denominator, and numerator and denominator should correspond. When you use dimensional analysis, the units will be diagonal because you're multiplying, so those will reduce out. Okay, so let's take this. This is a 6-foot diameter pool, and you need to know a couple of facts there. The circle formulas, you've got circumference, that C is circumference is equal to 2 pi r, and A is area. Area is equal to pi r squared. And then on a cylinder, the volume is pi r squared times the height. So this is a cylindrical pool, so I'm going to be using that formula for volume. And by the way, notice that cubic feet is a volume, right? And gallons is a volume. Remember, the cubic units are volume units. So the volume is equal to pi r squared times h. Now r, it says, since this d, by the way, you know r is 1/2 of the diameter. Since the diameter is 6 feet, then the radius is equal to 3 feet, right? And it also tells us that the height, right, we've got to have radius and height for our volume formula. The height is 40 inches. So if the height is 40 inches, let's talk about that for a second. Notice that we know that 1 cubic foot is 7.48 gallons. So similar to what we did with the gravel, we changed all units to yards so we could calculate cubic yards, because cubic yards is was the cost. It was cost per cubic yard. This we want cubic feet. so we can convert it to gallons because we know how fast the hose fills in gallons. And so we probably would be best to change this 40 inches to feet, so all the units are in feet. So I'm going to change that to feet. We know that 12 inches is equal to 1 foot, so our inches will reduce out, and we get 40 times 1 over 12. And 40 over 12 is like 20 over 6 or 10 over 3. I think it's 3 1/3. So I'm going to write 3.3 repeating is what your calculator is going to give you. And I'm going to leave it like that. Now you can't put an infinite number of 3's on your calculator, but you can put quite a few. Or if you put that in your calculator, you get 40 divided by 12 on your calculator and you get 3.3 repeating. Just leave that number in the calculator and you won't have to worry about it. Because what are we going to do? Isn't it one of the first things we want to do is find the volume? And the volume is pi times, now remember the radius is 3 feet, right? Half the diameter. And then the height is that 3.3 repeating. So now keep in mind, radius squared means we're going to get 3 feet really times 3 feet. And then the height is 3.33 feet, 3 repeating feet. So we get feet times feet times feet. So that's cubic feet when we're all done, right? So now I've already taken 40 divided by 12, and 3.3 repeating is already in my calculator, right? You can see the number there. So I'm not going to clear it. I'm just going to hit times 3 squared, or I'm just going to put in a 9. And now pi. Now how do I multiply that by pi? So you may know that pi is approximately 3.14, and that would be fine to use that in this problem. You don't have to have perfect, I mean, this is a pool we're filling with water, so how precise do you need to be? Not terribly. So this is 3.14 would be fine to use, but we do have a key in our calculators, and I'll show you, if you didn't know this, on the TI-84 and many calculators, they have a key that actually gives you pi exactly. So I'll show you that here and just take just a minute to do that. As this opens up, you'll see, well, I can show you where it is on this. Now I can show you better on this calculator. Okay, so if we take a look at the calculator, let me get quite a bit bigger here. Right over here, above the caret for the power key, there's a pi. It says right there is pi. So you hit second pi. So I think I already put in the numbers, but wasn't it? It was 3.3 repeating. So I think it did 40 divided by 12 is what I had already, right? That's how we got that number to begin with. And then it just went times, the 3 squared is 9, and times pi goes second pi, and that gives me pi a little more precisely. So 94.2477. That's our volume. So how really precise should we be there? I'm going to round off anyway to 94. I'm just going to say 94.25. And I'm going to use that. That's cubic feet. So now I've got 94.25 cubic feet. I'm going to multiply that. I'm going to convert that so I have gallons instead. So I want to have cubic feet down here and gallons up here. And that's 1 cubic foot is 7.48 gallons. And at the same time, notice I've got this 5 gallons in 2.25 minutes. I can write another unit ratio. 5 gallons, since I've got gallons here, and I want to know how much time it will take, right? How long will it take? I'm going to put gallons down here and then the minutes up here. So this 5 gallons is 2.25 minutes. And that's all it is. You calculate the volume, you multiply that, the units here are going to reduce out, right? The cubic feet will reduce, the gallons will reduce, and we'll be left with minutes. So I'm going to take that number that's still in my calculator, right? I've got that 94.25 in my calculator still. I'm going to multiply it by 7.48. I'm going to multiply it by 2.25, and then I'm going to divide by 5. So I'm going to multiply 94.25 times 7.48 times 2.25, all of those, and divide by, this is just over 1, so that's 1 times 1 times 5, and that's going to give me minutes. And so that ends up being 317 point whatever 238 minutes. I'm not really worried about that because that's way too precise for a hose filling a pool. And now we might want to convert minutes to hours because that's that large number of minutes. Well, how much is that, right? Well, to change minutes to hours, of course, you divide by 60, right? That'll get rid of minutes. And so I'll just take my answer, divide by 60, and we've got how many hours it'll take, and that's 5.28 hours, or about, right, about 5.5 hours, or about 5 1/4 hours, or 5, I'm just going to say 5 hours, and about, it's a little more than, but about 5 hours and 15 minutes, okay? It might not quite hit exactly 40 inches, but, you know, it's a little backyard swimming pool. Okay, so I'm going to pause right there. This will be part 1 of the geometry videos. I'm going to do a different one because this is 25 minutes is plenty long. Okay, so we'll do more later.